Hello, this is the presentation for the final project of Social Data Mining Techniques, Group 6. The agenda for the presentation is to collect a data from a source using the following methods as mentioned, which is web scraping, and the type of data which can be changed after some certain interval of time, and export the CSV files collected to a cloud database service, which will be Azure MS SQL database. We need to perform sentiment analysis and image classifier using cognitive AI for this created data, and finally create a story using a data visualization tool. About the data source, Popular Mechanics has been the authority on how world works. It is one of the websites which partners with brands like car, driver, road track enthusiast brands such as Runners World and Bicycling. The dataset is against the 7 best motorcycles to ride this year. And just to back with one more fact related to the dataset that in 2021 by Autocar India, the bike and scooter sales have witnessed a growth in the sales in this year, particularly in 2021 since June. So the links are provided here for reference. The data model for our project is first to collect the data and then perform the analysis, sentiment analysis, image classification, and then also side by side add all those things into a cloud database for us to be able to access it over cloud, and then put that data into a data visualization tool. The team members are Mani, who is the application developer and who is responsible to work with the CS development over Visual Studio and the cloud database. Madhuri Sharma is our Power BI analyst who will be showing us the visualizations that we have achieved. And Nilanjana Chawla is the data analyst and a Python developer who has worked on the sentiment analysis for the dataset. And I am Ayush Sharma, a business analyst who has been responsible for the sources and the scraping of the data. Tools and technology that we used are the Python to collect data from web scraping with the help of Beautiful Soup library and request library. We scrape the data into Excel files and to CSV files, in fact, and to query our collected data, we saved it into our SQL database over cloud on MS Azure, and finally created a dashboard to present the visualization in Power BI, Microsoft Power BI. The distribution libraries used here are with the CSV for the reading and writing of CSV files. NLTK is essential library supporting tasks such as classification, stemming, tagging, parsing, tokenization in the Python, and Beautiful Soup is a library for fetching the content from the websites by removing the markups in HTML. So now I'll move on to Jupyter Notebook. So these are the libraries, the import request library which we have used for HTTPS and the Beautiful Soup and the CSV writer. This is the URL for our data source, and so once we call one of the HTML tags here, header, so we can see all the content in the particular website. While the CSV file is being edited, we'll iterate over all uh, condition that we provided here, and these are the objects that we created that we require for our variables that we want in our CSV file. So one is the bike name, bike site, price, description, metrics. So once we run this particular code, we get this result: the bike name, the motorcycle website, the price, description, and the metrics. So now I'll request Nilanjana to take forward the presentation. Thank you.
Thanks, Ayush, for the quick overview. Now I, Nilanjana, will be covering the sentiment analysis and the database part for this assignment. As discussed earlier, the previous Python file was able to fetch our bikes data from the popular bikes URL. Now we need to perform the sentiment analysis, that is the positive, negative and neutral sentiments of the description column. So let's first discuss what sentiment analysis is. Sentiment analysis, also known as opinion mining, is a contextual mining of text which identifies, extracts subjective information in the source and helps business to understand the social sentiment of their brand. We will be performing the sentiment analysis using Wadir Sentiment Analysis package. This package provides us the measure of the positive, negative and neutral sentiment. Next, we will be using TextBlob. So TextBlob offers the API access to different NLP tasks, one of which is sentiment analysis, and it also helps us give two segments, polarity and subjectivity. Now I will be discussing the Python code for the sentiment analysis score. So this is my Python file. Before we proceed with our libraries, we need to also install some packages through Anaconda prompt. These packages include pip install TextBlob, feed parser and Wadir sentiment. Now let's proceed with importing the libraries. The first library is the import regular expression. So RE stands for regular expression, which is used to parse the title and store it in the database. Next is a feed parser. Feed parser is used for parsing the description here. Next, string. String is used to convert the scraped description into string format and then it inserts into the database. Next, an important library is NLTK. So NLTK stands for Natural Language Toolkit, which is used for building programs for text analysis. Then is NLTK download stopwords. It is used to remove all the unimportant words from our text. Later, we have the Wadir sentiment library. This is used for the Wadir analysis for sentiments. Next, we are importing pandas as PD and we will be storing the file which we got from the previous bikes file. Then we will be storing the description into a new data frame, that is description df, and we display the result. So here we are getting the description which we will be utilizing for our sentiment analysis. Later on, we will be using TextBlob. So TextBlob offers an API access to different NLP tasks, which is used to further return the polarity and the subjectivity segments. Next, we will be moving this data into a CSV file, which will then be used to connect to the Power BI and display the results. So this is the file which we got, and it includes my sentence, that is the description, a polarity value and a subjectivity value. Then we move on to the sentiment and intensity analyzer to get the three sentiment scores, which is positive, negative and neutral. So this is the code we used. We are passing the sentiment score from the text block, then we are getting the sentiment score from the Wadir, and we are displaying the description and the sentiment total value. Now, using these, we will be storing them in these lists, and we will be getting the positive, neutral and negative sentiments. And as we go further, we are able to see that there is a description, then a total sentiment, then there is also a compound value, a neutral score, a negative score and a positive score. This score is further moved into a CSV file using the command dataframe.toCSV and the file we want to name it. Here I have it on my local, so this is the file name. We have all the 5 columns that we need, and now I will be exporting the 2 files, that is bikes, which contains my polarity and subjectivity, and the sentiments, which include the positive and negative. After exporting, I was able to get the table. Now, if I run the query, we will be able to get the desired result. So this is the sentence, polarity and the subjectivity, and the second table. We can fetch the rows. Now, here we get the positive, negative and neutral for these fields. Now, Mani will continue with the image classification part. Thank you.
Hello everyone, I am Mani. So I am going to represent the image classification section of the project. So to do the image classification, I have selected the .NET Console application project and I have done code in C# to do the image classification. So let's have the look of the project, how the codes look like and how it works. So to do the image classification in C#, I have first downloaded 2 packages which were mandatory or required to do the classification in C#. First package is for the prediction and another one is for the training. And let's check the code. So to do the classification, initially I have passed some keys and endpoints and resource ID. So I have first passed the training endpoint and then training key. Same is for the prediction, but I have also passed the prediction resource ID, which is required for the prediction methods. So initially I have created new resources, which is custom vision prediction and custom vision training, and I have got my keys and endpoints and resource IDs from here, and same is for the training. I got the keys and endpoints from here, and I just copy paste the keys, endpoints and resource ID from the custom vision, and I have passed that in the code to connect my code with the custom vision. So as I'm doing the image classification over the bikes, so this is the list I have created for Ducati bike, then Harley, then Honda Monkey, Kawasaki Ninja, KTM, Triumph and Zero SRS. So these are the list I have declared here in the initial part of the code. Then I have declared some tags for each and every type of the bike. Then I have declared iteration, and in my initial method I have first authenticate the training and then authenticate the prediction. To do so, I have used the endpoint and the training key, which I have declared in the initial part of the code. And then this is the method that I have used to authenticate the training and the prediction. Then I have created the project. While creating the project, I got the ID of the project, which I have used further in the code to to add the tags in the project, to upload the images or to train the project. So after creating the project, this is the code to create the project, and I have created different tags for the different bikes. So this is the tags name I have provided. I have passed this, and I have created these tags in my custom vision project on Azure by passing this project ID, which was required to create the tag, to run this tag, create tag method or functionality. List. So I am passing all these folders which are in this location of the code. So this code is fetching the images from this particular folders which are here and passing these all images to these lists. So after this, the next method was upload images. So what this method is doing, this method is uploading all the images which are in list to the custom vision project. So I have used two types of code to upload the image. So this is the code which will run and upload image one by one. So this will run in loop. But this part of the code is uploading the image in one go. That means it's uploading all the images inside the folders in one go. Then the next method is train project. This method, I have used this method to train my project. And this particular part of the method will wait as the train method, or while training a module or project, custom vision takes some time. So this particular part of the code will wait for the method until its status become trained. So after when it's trained, it will run the next part of the code, which is publish iteration. So this method will help to publish our iteration. And to run this method or to make this code work, I have passed the project ID and the iteration ID. Here's the project which I have created. So these are the tags, and this is the prediction. This is the prediction ID which I have passed in the code. And let's check the predictions. For now, there is no prediction right now. So let's run the code to do the prediction. So first, I will do the prediction on the. Let's do the prediction on this image. But this is in Honda Monkey, and I have already passed this in my test image. So the first testing will run on this image. So let's run the code and check the prediction. This is the console window, and it says that the prediction is the bike percentage is 100, which means it's a bike. And this is the bike tag, which is common for all bikes. And these are the different tags for different type of the bike, and it says that this particular image is Honda bike, which is 68.9%, which is correct. And let's see the same prediction. It's reflecting on custom vision or not. So yeah, the same predictions come automatically here from the code. So let's do another prediction on another bike. So for the next prediction, I'm selecting this Harley bike. So I'm just copying the name and passing the image in the code, running the code to do the prediction over this image. So yeah, the code is working, it's making prediction. So let's check the window. So as per the prediction, it's a bike which is 100% and it's a Harley bike. So our prediction is correct. It's a 79.4% Harley bike and it's 34.7 somehow matching with the Kawasaki Ninja's 11.6 with the KTM. But the right prediction is it's a Harley Davidson bike which is 79.4. So yes, this is how the image classification code is working in C#. And the next part of the project is visualization, which will be explained by Madhuri. So thank you.
Thank you, Mani. So let's move to the visualization part of the assignment. We have used the topic Top 7 Bikes of 2021. So we have created a dashboard with home page on it. As you can see, we have used 7 buttons with the name and bike image used, which will lead us to the respective screens in the Power BI dashboard. So let's move to the first screen. Once I'll click here, I'll be redirected to the Ninja tab. Here, what we have done is we have imported the data by making the connections with the Azure. We provided the server name and the Azure credentials to make a connection. Once the connection was made, by providing all the required tables, we were able to fetch the different type of tables we are using here. One table is one which was actually scraped initially, which was having only the initial data. In another tab, we are actually calculating the other polarity and the subjectivity value. And from the third one, we got the sentimental, positive, neutral, and negative aspects of the data. Now on this dashboard, as we can see, we have different type of visualizations showcase that will outcome. So starting from here, we have the image which was used in the custom vision to fetch the predictions. So this image was uploaded and the visualization specifies all the values which are found in the prediction for that iteration. Now, second is the cloud map. For the description, we have scrapped for the Ninja bike. We have removed the stop words from the description, thus it shows these values. If we go to some other tab, we can check that their word map is somehow different because the values coming there is totally different. So I'll quickly go from here. I'll just redirect to the KTM one. So we can see the data here is totally different. So now next we have the price of the bike. The visualization shows only the price of that particular bike. So we have $690 for the KTM bike, the price of the bike. If I go back to any other bike for Ducati, we can see the price is different. So next we have the sentimental value shown using the gauge visualizations. We have added up sentimental visualizations for all of the visualizations of bikes. Now we can see that from the sheet we have represented the positive, negative and neutral values for all the different bikes and have used the bar graph type of visualization to show the cases. Here it means that the positive one was around 85%. So when we go here, it hovers the average of the positive and it shows the particular description. So it was like positive aspect were 85% here. And now we can see that we have the representation in the form of the donut chart. It gives the polarity and subjectivity depending upon the bike we have. So if I'll go quickly to any other bike, I'll be able to see the polarity and subjectivity varies here. Finally, we can just move to the home button, and then whenever we want to see any particular type of visualization for a particular bike, we can just click over here and we'll be just able to redirect to it. So coming back to the PPT, we have added up all the screenshots for the dashboard and one of the kind of the particular visualization for a particular type of bike. So to conclude, we have used different type of charts. One was showing for the probability of the custom vision. The second one was the word cloud map. Then we used the bar graph to show the positive sentiments, and then finally we added up a donut chart to show the subjectivity high percentage. And I would like to thank you for watching our presentation on the behalf of our group number 6. Thank you.